There are more and more cars using 800-volt architecture. Can the early 400-volt charging pile charge 800-volt batteries? Today I will introduce the DC-DC boost circuit on pure electric vehicles. The Toyota Prius was the first model to use a high-voltage boost circuit, which boosts the 201.6 volts output from the battery to the motor controller to 500 volts. So how does it work? The DC-DC boost circuit includes a switch, a diode, a capacitor, and an inductor. We take one battery to two battery circuits as an example to illustrate its working process. In the initial state, the switch is closed. Since the voltage of two batteries is greater than the voltage of one battery, the diode is in cutoff state. Since there is only one inductive element in the line, the current rises sharply, and the inductor will burn out if it is powered on for a long time. In practice, the inductor only works for tens of milliseconds, and at this time, the electric energy is stored in the inductor coil in the form of a magnetic field. When the switch is turned off, the current in the inductor suddenly decreases, and a back electromotive force is generated in the inductor. The voltage of the back electromotive force is the same as the power supply voltage. At this time, the voltage between the output terminal and the ground is equal to the sum of the inductor voltage and the power supply voltage. When the sum of the voltages is greater than the voltage of the two batteries, the diode is turned on, and the low-voltage circuit starts to charge the high-voltage battery and capacitor. The main function of the capacitor is to stabilize the voltage. After charging for a period of time, the diode is in the cutoff state after the inductor voltage drops. At this point, the switch is closed again. The inductor begins to charge again, and this cycle continues to output high voltage. The control waveform of the switch is shown in the figure. The purpose of the switch closing is to make the current reach the maximum target value, and the purpose of opening the switch is to make the current drop to zero. The ratio of the input to output voltage of the circuit controlled by this connection is 1 to the difference of 1 and the duty cycle. If the duty cycle is 50%, the output voltage is twice the input voltage, and the output voltage of the line can be controlled by controlling the opening time of the switch. This is how a DC-DC boost converter works. Well, that's all for today.